Hi, Assalamualaikum. My name is Muhammad Aiman Hakim. My number metric is S73056. So for the question 1 is the task involves generating, analyzing and comparing two discrete time constant signals X1N and X2N using Matlab. Both signals were visualized using the subblock function in Matlab to clearly showcase their differing behavior. X1N further slower oscillation and a lower amplitude, while X2N exhibit faster oscillation and a higher peak value, resulting from its greater frequency and amplitude. This observation highlights fundamental principle of discrete time signal processing, especially how a signal frequency, amplitude and phase effect is shaped.
Assalamualaikum and hi everyone. My name is Karmisa Shafia binti Kamar Nizam. Would like to discuss question 2, which the code was given. And let's talk about the signal, which x of t equals 5e to the minus 0.3t times e to the j16. First, the first number 5 just tells us how big the signal starts out. The part with e to the minus 0.3t means the signal gets smaller over time, like turning down the volume. The e to the j60 part makes the signal spin or wobble like a wave, because in math, as we know that j stands for the square root of -1 and makes things rotate. So the signal is like spinning wave that starts strong then fades away. We can split it into two parts, a cosine wave, real part, and a sine wave, imaginary part, both getting quieter as time goes on. Now let's look at the magnitude and phase. Magnitude is how strong the signal is at any moment. The graph of the magnitude is a smooth line that goes down from 5 to 0. Then phase is a bit different. It tells us how much the signal has moved around in a circle over time. This means the signal is spinning at a steady space the whole time.
Assalamualaikum. My name is Muhammad Haji Azran bin Muhammad Zaid, S73016. Today, I will explain about question number 3. In part 3, 3 discrete time signals were generated and plugged using Matlab. All signals were defined in the range from n equal to -6 to 6. The stand function was used to display this signal clearly as discrete plug. This step helped us to visualize the shape and structure of each signal before applying convolution. This is the result for H1n, H2n and Sn were generated. The input signal Sn was first passed through system H1 and the result was called Vn. Then through Vn, the final output Yn was generated. Using the Matlab convolution function was used for both steps and the signal were plotted to show the result. This shows how a signal changes when it passes through two systems in sequence. Next, in part C, the order of the system was reversed, so there's a new convolution that was generated. Again, the Matlab was used to calculate and plot both Vn and Yn. The result for Vn looked different compared to part B, but the final output of Yn was the same in both cases. This confirms that the commutative property of convolution, meaning the order of LTI system does not affect the final
result. In this problem, we are looking at two signals. The first one is a short, pointy bump-like triangle that shows up for a few seconds around the middle of the graph. The second signal is a wavy line that starts at 0, goes up and down, but gets smaller and smaller over time. Now, convolution is a way to combine these two signals. Slide the triangle over the wavy line and at every spot, you see how much they match up. The result is a new signal, new line, that shows what happened when you mix together. When you look at the graph, you will see the triangle, the fading ripple, and the new signal that is made by combining them. This new signal starts when the triangle and the ripple first meet. It gets its shape from both, and it fades away as ripple gets smaller.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Afiq bin Muhammad Syukri. Nombor metrik S73049. Saya akan bahas untuk soalan nombor 5. Okey, untuk soalan A, kita akan kira dan plotkan impulse response untuk H kurungan T. Kita diberi fungsi frekuensi H kurung omega dan dapatkan H kurungan T. Kita kena gunakan inverse Fourier transform. Okey, yang kita tahu H kurungan omega sama dengan 4E kuasa negatif J 3 omega. Okey, bila kita lakukan inverse Fourier transform ke atas H kurung omega, kita akan dapat H kurungan T sama dengan 4 per pi darab sin kurungan 2 per T tolak 3 per pi. Okay, dalam Matlab, kita akan masukkan kod yang seperti yang saya tunjuk dalam gambar ni dan kita kira dan plotkan HT gunakan fungsi sin dan kita akan dapatlah untuk signal input dan output. Okey, untuk soalan seterusnya, untuk B, kita kirakan output bila input xt sama dengan sin 4t. Dalam sistem LTI, output yt kita dapat daripada convolution antara input dan impulse respon. Yt sama dengan h kurang t convolution xt. Jadi kita gunakan fungsi convolution dalam Matlab untuk laksanakan convolution ni secara numerik. Lepas tu kita plotkan kedua-dua xt dan yt dalam satu figure guna subplot, dan kita akan dapatkan signal input dan output untuk xt. Untuk soalan seterusnya adalah C. Untuk bahagian ni kita bina gelombang petak dengan gunakan full series sampai 12 harmonik, dan kita gunakan formula x kurungan t sama dengan n sum 4 per nt darab sin darab kurungan 2 pi nt per t besar. Lepas tu kita jumlahkan semua komponen sinusoid ni dalam Matlab guna loop. Lepas tu macam biasa kita tampil signal ni guna impulse response ht dalam fungsi convolution, dan last sekali kita plotkan x kurungan t gelombang petak dan y kurungan t output.
Hi. For question number 6, a third order differential system was analyzed using the Laplacian transform to better understand its dynamic behavior. The transfer function h was derived and implemented in Matlab for further analysis. For pole zero analysis, it was observed that all poles lie in the left half of the complex plane, confirming that the system is stable. The impulse response ht was determined using the partial fraction method. Specifically, through the decision technique, as expected from the stable system, the response exhibited exponential decay. This thus effectively demonstrates how Laplacian transform technique combined with Matlab tools can be utilized to analyze to interpret the behavior of learning system and brain system.